Challenge trigonometric equation. Here's a very difficult trigonometric equation to solve. Question 1. Solve 2 cotangent x plus secant square x equals to 0, where x is greater than equal to 0 and less than equals to 2 pi. Okay. Now, we will use some identities here. Secant square x can be written as 1 plus tan square x, correct? I hope you remember that. Secant square x is 1 plus tan square x, and cotangent is reciprocal of tangent, right? So we can write this equation as 2 over tan x plus secant square x I am writing as 1 plus tan square x equals to 0. Now this particular identity replacement helped us to write the equation in the form of tan. Do you understand that part? So that is why we wrote it. Cot is 1 over tan, so we get 2 over tan x, and secant square x is 1 plus tan square x. That is the Pythagorean identity, right? Now we can multiply both sides by tan, right? And remember, since tan x in the denominator, tan x cannot be 0 for our solution. It may be within 0 to 2 pi, but it cannot be 0. Okay. Now let's multiply both sides by tan x, and then what do we get? We get 2 plus tan x plus tan cube x equals to 0, right? So that gives us a cubic equation in tan. Now, we'll use the strategies learned in advanced functions to solve a cubic equation, right? So let me rewrite this equation as tan cube x plus tan x plus 2 equals to 0, right? Now, let's say that tan x is y. Okay, let me just say, let tan x equals to y, right? We don't know what it is, right? The whole purpose is to find what that value is. So we get y cube plus y plus 2 equals to 0. Now this is a polynomial equation of degree 3. Now to solve this equation, what we can do is, we can find what values, factors of 2 which will satisfy this, right? So the factors of 2 which could be possible solutions are plus minus 1 or plus minus 2, right? So the factors of 2 are, so basically what we're trying to do is, we're trying to find out value which when plugged in here will satisfy the equation, right? So those will be factors of 2, right? So factors of 2 are either, so we have solution either plus minus 1 or plus minus 2. So we can test it out. Since all of them are positive, plus values will not give you 0, right, when added? But minus values can, right? So if you plug in minus 2 here, you get minus 2 cube is minus 8, and minus, this is minus 2, minus 8 minus 2 is minus 10, plus 2 will give you minus 8, not 0. But how about trying with minus 1? Let me put minus 1 here. So minus 1 cube plus minus 1 plus 2 equals to what? So minus 1 cube is minus 1 is minus 1. When you add them, you get minus 2. And so you get 0 equals to 0, right? So that means minus 1 is the solution. That means y equals to minus 1 is the solution, right, for this equation. Correct? So we will use this solution and find what tan x could be, right? So we get one solution, that is y equals to minus 1. So now look into tan function. Now we have tan x equals to y, that means tan x equals to minus 1. Now tan is negative 1 only in 2 quadrants. Either you are in quadrant 2 or in 4, correct? And that too for pi by, so it is acute angle of pi by 4, right? So this should be pi by 4 to give you 1. So tan is minus 1, so this is 1 pi by 4, 2 pi by 4, this is 3 pi by 4, and this is 1 less than 8 pi by 4, which is 7 pi by 4, okay? So these are the two values which we can get for tan x, correct? And therefore we say x is equals to 3 pi by 4 or 7 pi by 4. Okay, so that is our solution within a domain of 0 to 2 pi. Okay, so right answer, x equals to 3 pi by 4 or 7 pi by 4. Now this is a very critical question, and you understand the strategies which we adopted to solve it. Strategy was to write the equation in terms of tan, and we used the Pythagorean identity, that was 1 plus tan square x equals to secant square x, right? And you know tan is reciprocal of cotangent. So that is how we are going to solve it. I hope you understand and appreciate the method. Thank you and all the best.